How you guys doing? Today we're going to do similar right triangles. This is a good example of one. This problem has 3 triangles in one. Let's go to it, see how it looks. So what we're going to do now is look at this big triangle here, ABC, and these 2 little triangles, ABP and CBP, and then separate them so that we get this effect, and then we can compare these similar right triangles. Now, they're all right triangles, they all have 90 degrees in them, and they're similar. So the easiest thing to do is look at this one right here, because it's already facing this way. Think of it as a boat with the front going straight out here, the stern's going straight out into the water and moving this direction. So the boat's going this way, the 8 here, the PC is the PC here. This X is the hypotenuse, and what is this? Well, in order to really remember what a hypotenuse is, I think of this 90 degrees as a projector. And the projector's got a movie that it's showing, and it's projecting light onto this hypotenuse, the opposite screen, the opposite side. That's the hypotenuse. It's X, and it's X here. They're lined up, so they make sense, right? They're already in line, they look similar, and we have C, B, P. Let's look at this one now. The boat's going the wrong way here. It's facing the wrong direction. The stern's going that way. So we just flip it over, and we get this to be this. And we have our 90 degrees here, but we've taken the A and moved it all along. So there you go. It's still 5. AP is 5. And our hypotenuse is with a tick mark here. AB is now on this side. This double tick mark indicates this one here. I put that in there after this problem was put down, just to indicate that this line is the same as that line. They actually share it here, but when you separate the triangles, you want to make that distinction. So we've got 2 triangles to compare. The only problem is there's no other side length here that we can really compare it to, so we're not sure if we're going to use this one. So let's look at this bigger one. This bigger one here is flipped over, so we've got that 90 degrees at the top. We want to bring that down to the bottom. So when we do, this is how it looks. We've got our hypotenuse, which is 13, is 5 plus 8. So see our bottom here, how that's the hypotenuse coming away from this right here, shining onto that movie screen, that's 13. And then we have X right there, that's BC right here. And then BA, that's the part that goes out into the water, the stern. That's the direction we're going. So we've lined them up so that we can compare them, and what we really want to do in order to get a proportion is compare these 2 triangles. That's going to give us what we need. So if we look at this, we can look at 8 over X. In other words, one side over the hypotenuse of this one is compared to a side over the hypotenuse of the other one. So now they're the different sides, so it's going to look like this. 8 over X equals X over 13. That's the proportion we want. And then what we're going to do is cross multiply. X times X is X squared. 8 times 13 is 104. And then we're going to take the square root of both sides in order to get the answer. So what we ended up with, I'll take that off for a minute because I wrote it ahead of time. But this is what you're going to get. X squared equals 104. And then you're going to say, oh, what do I do now? I'm going to add this in. I'm going to take the square root of both sides. Square root of X squared is X. And then the square root of 104 ends up being 10.2. If you put that in your calculator, that's what you'll get. And there's your side length. So now we have 10.2 here, we have 10.2 there. And we can compare those triangles, and we've got the missing side length. So again, finding missing side lengths by comparing similar right triangles. Let's go to another example, a little bit different, and let's see how that works. All right, so zooming in here, we've got this triangle and this triangle. I want to look at those specifically. If you take this triangle and just lower it down, you see that ABD, with the B facing out like a boat on a stern going out in the water that way, is an exact reflection of that. That's it right there. And I even did it down here as well. It's the same thing. This, and this, same thing. Now, when we look at this one, we have to be careful, because what happens is, maybe we flip it over and we try to compare these. Well, the thing is, the problem is that's not what this problem is telling us. This problem is telling us that ABD is similar to CAD. So this is not CAD. It's not a flip. It's not a move in the same way. If we were to compare these, we would notice that this would line up and this would line up, and we really couldn't do a proportion if we did that. So what you have to look at is CAD, not ACD. CAD goes like this. Again, let's look at it more carefully. Remember, CAA is where the right angle is, and D is down here in this triangle. So that triangle means the right angle is at the bottom here. The 10 is right here, is actually this line right here. And the X value is right here. So that's AD is right here. That's X, and it lines up with that. And then we're comparing that to that first triangle we talked about, which looks at the D, or it's ABD. So that's how that works. Okay, so just to make sure you understand, this is wrong, okay? This is actually wrong because this is not oriented right, and we're gonna put a line through this and say, hey, that's not a good way to compare these because it's not the way that this is saying. This is saying triangle ABD. That part's the same as that. ABD is similar to CAD. The D is in the same position now, but the point of this thing is A for this one and B for that one, and then the last thing is D, so that would be right here, the same thing here. So we've got to make sure you orient it properly in order to compare them. When you do that, you've got DC right here, the base. What we've done is really kind of flip that over and moved it around so that it looks like this and it lines up with that. That's really what we've done. So it's very tricky, and that's why a lot of people have problems with these. They have to be lined up properly, and this similarity of triangles has to be looked at properly in order to compare them. When we do have them lined up, we can create a ratio because we can compare the sides. The ratio we get is x over 10, right here, x over 10 is proportionate with 3 over x. Let's just go over it again. So in other words, the base over the side right here, coming up from the right angle, is x over 10, is proportionate to 3 over x. So that's why we lined up these triangles in order to be able to compare them. The base over the side length, which is coming up from the 90-degree mark, is comparable to 3 over x. Now we have our proportion, and we can cross multiply. X times x is x squared. 10 times 3 is 30. That at this point right here, what we're going to do is take the square root of both sides. So we go like this. Boom. Square root of x squared is x. Root of 30. You can get that in a calculator, and you're done. That's what this is. X is equal to root 30, so we can fill that in as our answer here, and we're done. Okay, so I hope you understand that the clear and key thing is, in order to compare similar right triangles, we have to orient them differently. You have to look very, very carefully at what they're telling you, because there's a lot that can get very tricky if you don't read this carefully. You can't assume that they're going to give you the triangles in the same order as you think they should be or anything else. You have to really look at those carefully. So I would encourage you to check this video out and try them yourself and go over and over them until you really understand how this works. Thank you.